right, so you guys, what we are going to talk about today is something that is familiar to you. You guys did last year domain and range in Math 1 with linears and exponentials. And now we are going to take that and we're going to apply it to quadratics this year. If you forgot, domain is all of your x values, range is all of your possible y values. Okay. However, this year we are going to use something called interval notation, and that's just the way we are going to write out our domain and range values. It's a new set of notation that you guys haven't seen before. If you remember, I mean, this could be way back when for some of you, graphing on a number line like this, sometimes you'd have this, whatever, and doing open and closed circles like this, and then maybe filling out in between everything. We're taking it back to that. However, instead of doing it with open and closed circles, we are going to use brackets and parentheses. So brackets are used when we want to include the value. So that is similar to your closed circle when you used to graph on a number line. Okay. And parentheses are used when we want to exclude the value. And so that is your open circle when you used to graph on a number line. Okay. Now, what you want to remember when you used to do this on a number line, if you are including a value, there are a couple of different times to do that, but what you want to look for to start is if you have the equals to with your inequality, so greater than or less than or equal to or greater than or equal to, would have a closed circle when you graphed, which means in this case a bracket. And when I'm talking about brackets, you guys, this is what they look like. Okay. And then parentheses are used when you want to exclude the value, which means you don't have the equals part in your inequality, so just a less than or greater than sign. And then parentheses, obviously we know what those look like that. So you guys, if you are somebody who maybe might be a little sloppy or maybe writes too fast, this is a time where you need to be really careful in how you write these, because it's very easy if you are sloppy for me to confuse a bracket with a parenthesis. So please make sure that you take your time with this stuff. So the only other thing we're going to talk about is infinity. Okay, so if you ever see infinity or negative infinity, which we'll talk about in a minute, those always get parentheses because it's not a definitive number. You can't put your finger on infinity. So those are always parentheses no matter what. Okay, so what this all means is if you have something like last year that reads as x is greater than 10, okay, so let's say that we have x is greater than 10. Well, that means, and I'm not going to do number lines for every single one, but just to give you a visual, if this is the number 10, x being greater than 10, you guys, means I'm going to have an open circle at 10 because I don't have an equal sign, and I want everything bigger than 10, so everything this way. Okay, now that's old math, how you used to do it before now. Now we're going to write it in interval notation. So the way that looks in interval notation, I don't want to include the 10 because it doesn't have an equal sign and therefore an open circle. So I'm going to have a parenthesis and I'm starting at 10. And then I don't have an ending value. So since this is going on forever, that means it ends at infinity. So this is the inequality notation of x is greater than 10. This is the interval notation. This is saying all of the x values between 10 and infinity. Okay, so for the next one, if I have x is less than or equal to 0, so again, you can think of it on a number line. I'm going to drop these soon because we won't do them every time. But less than or equal to means we're getting a closed circle, and I want everything less than that, so this way. Okay, well, if I'm going negative, remember, this is infinity, this is negative infinity, right? Positive, negative. So same thing. This is going towards negative infinity. So that means that your interval notation for that green area would be from negative infinity. It starts all the way at the left and comes up to 0. But now I'm including that 0, so it's going to get a bracket. Okay. For the next one, x is less than 22. So again, if it helps have a visual, if we're on the number line at 22, I have a open circle at 22 because there's no equal sign there, and it's everything less than that. So it's everything this way. So now, again, I'm starting at negative infinity until I hit 22, but that needs a parenthesis because it's an open circle. Okay, so if the number lines help you, feel free to write them. You do want to try and work your way away from them though. If you look at this next one, now we have two bounds, okay? This is saying all the x values from negative 12 to 5. And notice these are both just less than signs. There's no equals to. So I'm going to go from parentheses negative 12 to negative 5. Now, this is why this gets tricky. That looks like a coordinate, but you need to take the context into account. We are talking interval notation. So what this really means is all of the x values from negative 12 to negative 5, but I'm not actually including negative 12. That would be an open circle on a number line. And I'm not actually including negative 5. That would also be an open circle. Okay. For this next one, it says x is less than negative 3.8. So that means I want everything less than that, which means I'm going to start at negative infinity and go up to negative 3.8. However, I don't have an equal sign there. That's just a less than, so that gets a parenthesis. For the next one, we have negative 40 is less than or equal to x is less than 7. Okay, so now if you look, negative 40 is inclusive. So I'm going to have a bracket at negative 40. And then I'm going up to 7, but 7 is not inclusive. You're going to exclude the value because there's no equal sign with that. So you'll have a parenthesis. Okay. For the next one, it might help if you pause the video and do these next three on your own and then come back and see if you did them correctly. For this, we have x is greater than or equal to 17. So 17 is going to be my smallest value because x is everything bigger than that. But I want to include it. So it's a bracket of 17 because of the equal sign. And then it's everything bigger than that, so all the way up to infinity. And then here, excuse me, this is x is greater than negative 25.9, meaning negative 25.9 is the smallest number. So you want to always start with the smallest, so negative 25.9 up to infinity. Both have parentheses because infinity always has a parenthesis, and negative 25.9 has to have a parenthesis because it's not inclusive. There is no equal sign there. Now, down here, we have x is less than or equal to 17. So now 17 is going to be my biggest number because it says x is less than that. So I want to start at negative infinity, and my biggest number is 17, and I'm going to have a bracket there because I have an equal sign. Okay. So we're going to practice that a little bit more today. And then down here, we're just going to reiterate kind of what we started talking about in the beginning of the video. Your domain is all of your x values, and your range is all of your y values. Okay. So we're just going to take some time today to look at random graphs. These aren't necessarily quadratic, but we just want to focus on domain and range and understanding how to write domain and range for each graph in interval notation so that we can start using that with quadratics on a regular basis. This is something you'll see throughout the whole semester. So if you look at number 1, domain is all of your x values. So you guys, I'm only going to focus on what's happening here. Okay. Well, if you look at that, my graph doesn't start until here, until all of this. There's no graph at all, so I'm going to get rid of that. My graph doesn't start until 0. And then it goes along all the way, all these x values. This arrow, pay attention to arrows. This arrow means it's going on forever. So that means my domain, the first x value that I have here is 0. And because of this arrow, it's going to go on forever. Okay, so domain, you always want to read like a book, left to right, and only look left to right. So if you look, this arrow technically is going 2 directions. That arrow is going up, but it is also going right. So when you're doing domain, I don't care about the up part. The only thing I care about is it's going to the right, and that's what's causing the infinity. Now, I don't have an arrow on the left-hand side, but I do have a closed circle. Again, I don't care about the 1. I'm caring about the x value. This is the point 0, comma 1. I'm caring about the x value right now because it's domain. That is going to be an included value because that is a closed circle. Okay. Now, with range, I look up to down. So domain is left to right. That's what you're trying to figure out. Range is up and down. Okay. So now, instead of looking at my x values, I need to now look at my y values. So I'm looking vertically. Okay. Well, if you think about it, the first place vertically that this graph starts is right here. And then, remember I said this arrow is going to go 2 ways. Well, because I'm looking at range, that's vertical, I'm looking at this arrow is going up. So the very first y value, or the smallest y value this graph has, is the 1. And it goes up forever without an ending point, so it's 1 to infinity. And again, we have a bracket here because that's an actual point on the graph. It's not an open circle. It's not an excluded value. It is an actual point on the graph. Now, for the next one, we have 2 arrows that we're looking at. Okay, so again, domain and range. I only care about what's going left to right. Okay, look at the arrows first, you guys. This graph tells me I'm going left forever, and this tells me, well, it looks like it's going up. Remember, 2 directions. It's going up and to the right. So that means this graph is going on forever to the left, forever to the right. So your domain is going to be from negative infinity to infinity. There is no stopping point. In the first example, we had a specific starting point in this case. You could have starting, you could have stopping. So we didn't have an arrow. But here we have a double arrow. So we're going left to right, so negative infinity to infinity. With your range, again, now you're ignoring that, left and right, and you're looking up and down. So here, this graph is going up forever, so we know we're going towards positive infinity. However, let's look at this. Remember, we're looking at vertical values. Okay, well, this is an exponential graph. Hopefully you kind of picked up on that. Exponential graphs, if you remember I was talking about this last week, have intercepts with them. I'm sorry, that's a lie. They have asymptotes with them. So that asymptote, you can tell this graph is flattening out as it gets to 0. So while this arrow is going on forever to the left, technically it's flattening out at 0, which means I can never get a y value that is less than 0. So it starts there, and that is an asymptote at 0. So therefore, I'm going to have a parenthesis, comma 0, because remember from exponentials, this graph is going to get as close to 0 as it possibly can, but it's not actually going to hit 0. So you just have 0 to infinity for your range. Okay, so hopefully those were kind of review-ish because they are both a linear and an exponential. Now let's try it with a quadratic. Okay, so again, our domain is anytime my graph goes left to right. So if you look on the left-hand side, I have an arrow here, and then it comes down around and I have an arrow here. I don't care about the up. They look like they're both going up. Great. Save that for range. Domain is only left to right. So this arrow technically is going to the left forever, and this arrow is technically going to the right forever. So your domain here is negative infinity to infinity. All x values are possible here. Okay. Now, for your range, this is where we look bottom to top. Okay. So if you look at your vertical values, so just the y's, think about what we've been doing the past couple of days, you guys. All of these have a maximum or a minimum at blank, right? And that blank was a y value. So that's saying I have a maximum at a y value. I have a minimum at a y value. So it's saying there is some sort of cap on how high these graphs can go or how low these graphs can go. So, sorry, that's my lovely dog in the background. All right, sorry, we're back. All right, so these have a cap on where they can go. So we have in this case, a minimum value. And if you notice, that minimum value is down here at 0, 0. So the smallest y value You would have a min at 0. So that means your range is starting at 0. And it's going to infinity because both of these arrows are going up. Now, that's an actual point on the graph, so we're going to include it with our range. You guys, just a heads up, because of the way quadratics are, now, we are going to restrict domain at some point or restrict range and say, like, you can only have a certain amount of something when we get to context problems over the next few days. But with your typical quadratic, your domain will always be negative infinity to infinity, but your range is what's going to be restricted. And that's just because I can put any x value in, but you can't get every y value out. Okay. All right, now this next one is an absolute value graph, which we're just using for practice. It looks a lot like a quadratic in terms of a few of its characteristics. However, it's slightly different, which we'll talk about next unit. So domain, we're just going left to right. Okay, so if you notice, I have an arrow going all the way left and an arrow going all the way right. So if I were to think left to right, this graph's never stopping. So my domain is negative infinity to infinity. And then my range, I'm just looking bottom to top. Well, both of these arrows technically go up, right? So if these both go up, that means my range never stops. My y values are going to go to infinity. However, similar to quadratic, this has a lowest point here. Nothing is getting below this point right here, and that point has a y value. That's the point 3, 0. Well, I don't really care about the 3, right? That's domain. This is the absolute lowest y I'm going to get, so my range is 0 to infinity. Okay. All right, what I would do now is I would flip over your notes and I would hit pause and I would do these on my own, see how you do with domain and range. Again, you guys, I can't force you to do this, but if you really want to know if you know what you're doing, then do these two and then hit pause and I'll work through them. All right, so for this one, again, domain is my x values. I'm looking left to right. So this is going forever and forever. Sometimes I just exaggerate them to make it obvious. Again, left to right. Yes, those arrows are going up, but every arrow has 2 directions. This is going left and up forever. This is going right and up forever. So if it's going left forever and right forever, your domain is negative infinity to infinity. But range with quadratics will always be where you run into something that has some sort of restriction. In this case, we have a minimum. So if we were writing it like the last couple of days, that would be a min at -1. That means my smallest y value is -1, and then obviously these arrows go up. So I'm going to go from -1 to infinity. Okay. Over here for domain, I only have one arrow, you guys. This arrow is over here, but this is a starting point. So my domain goes from -2 with a bracket, because that's a circle, it's a point on the graph, it's not an open circle, to infinity because this arrow is going to the right forever. Now your range, same thing. This point is the point -2, 0. Again, I just did that, so I'm going to ignore it. The smallest y value we get here is 0, so I have to start my range at 0, and then this is going up, up, up. This arrow, remember, 2 directions. I don't care about the fact that it's going left forever because that's domain. Now I'm going to look at this in a vertical sense. That arrow is technically going also up forever, so the range is infinity. Okay, so you guys use arrows, especially when you're doing domain and range, but you really got to slow down here and think, okay, domain's left and right, range is up and down. Because a lot of people look at these arrows and like for this one over here on the left, they think, oh, they're up. But you need to remember it's always 2 directions. Okay. All right. I am going to do 2 word problems. Okay. And then let's see, which one do I want to do first? Okay. We'll do number 1 first. I had a note to do something, but it's cool. We'll go with it. All right. So we have a window washer who tosses his wet sponge from a height of 8 meters above ground level to his coworker above him. The sponge reaches its maximum height of 9 meters exactly 1 second later, but the coworker does not catch the sponge, so it falls to the ground. All right, you guys, don't care about any of the questions right now. Let's draw a picture and get an idea of what's going on. So we have a window washer who tosses a wet sponge from a height of 8 meters above ground to his coworker above him. It reaches a maximum height of 9 meters 1 second later. Hopefully you're thinking vertex, but then it falls to the ground. Okay, so if you're thinking of a quadratic, he's tossing it from a height of 8 meters. So we're talking about height, and then if you notice, it says exactly 1 second later. So we can infer from this that this is time in seconds, and this is height in meters. Okay, so he tosses his wet sponge from a height of 8 meters. You guys, if that's the starting point, that is the point 0, 8. Okay, and it says the sponge reaches its maximum height of 9 meters exactly 1 second later. So then we have this point, which is 1 for time and 9 for height, but then it falls to the ground. Okay, so we know just based on symmetry, if this is the maximum, then I can go ahead and draw on my axis of symmetry, right? So then I can also put a point right here at the point 2, 8 using symmetry, and just kind of give myself a little bit better picture. And then it hits the ground. Okay, so let's think about this. If I went from my vertex, I went right 1, down 1. Okay, that means if you're thinking in terms of ax squared, let's think about what our a value has to be. Typically, 1 squared is 1. Well, I'm going right 1, but now I'm going down 1 from 9 to 8. So that means my a value has to be a -1 because I'm still going a distance of 1, but I'm going down. Well, if my a value is -1, what if I go right 2? If I go right 2, then I'm going to go 2 squared, which is 4, but I'm going to go down 4. So I'm going to go right 2, down 4. I did not a great job drawing this graph. But then that would be the point 3, because now I've gone right 2 and down 4, so 3, 5. And then if I went right 3 to a x value of 4, 3 squared is 9 times -1. I'm going to go right 3 down. This is the point 4, 0. Okay, so right 1, down 1, right 2, down 4, right 3, down 9. Okay, now I have a nice graph and I can answer the questions. This says, after how many seconds will the sponge fall to a height of 8 meters? Okay, well, we went up, now we're coming back down. How many seconds did it take it to get back down there? 2 seconds. Okay. And then, what is the span of time that the sponge is in the air? Well, it starts here, travels up, and comes back down for a total of 4 seconds. Okay. All right, now this says, what is a reasonable domain and range for this function? Okay, so let's think domain. Domain is our x values, which is representing time. Okay, well, it starts at a time of 0, so that's where my domain is going to start, but then it hits the ground at 4 seconds. You guys, once it hits the ground, I don't care about it anymore. So I'm going to end my domain at 4. So all I'm looking at is the 4 seconds that this was in the air. Now for your range is talking about height. Okay, now we're always going smallest to biggest. So if you think about the smallest height of this is down here at 0 when it's on the ground. The highest height is its maximum at 9. So my height goes from 0 up to 9. That's the span that this will cover. It goes from 0 to 9. You don't want to do 9 to 0. You always want to do smallest number on the left to biggest number on the right. Okay. Now, for number 2, we have Amit, who is a diver on the swim team. Today he's practicing by jumping off a 14-foot platform into the pool. Amit's height in feet above the water is modeled by that function in standard form, where x is time in seconds after he leaves the platform. Okay. How long will it take him to reach the water? What's a reasonable domain and range? Okay, let's draw a picture. Cool. So if you look at this, this is in standard form. Okay. He's jumping off a 14-foot platform into the pool. So let's do a little bit of work here. Let's do our three main things, our vertex, and then we'll do x-intercepts and y-intercepts. So this will be x equals the opposite of b. All right, cool. So the opposite of b, in this case, there is no b, you guys. You see how this is just ax squared plus c? So that'll be -0 all over 2 times -16. Well, either way, that's going to become 0. And then y equals -16 times 0 squared plus 14. So 0 squared is 0 times that whole thing cancels out, and you're at 14. So your vertex is 0, 14 up here. And then, if you notice, not only is that our vertex, but that's also our y-intercept. So he's literally diving right into the ground, or right into the water. God, I hope it's not the ground. All right, so we need to figure out what that point is. Well, this a value tells me that typically I should go right 1, down 16, but then I already know I'm going to be down here. So let's grab our calculators and figure out what that x-intercept is, and then go from there. All right, so we have, I'm going to second plus 712 everything, so whatever was in there before, I'm good. And then I'm going to go to my y equals and type in my -16 x squared plus 14. And then I'm going to hit graph. You guys pause as needed. Make sure you do this on your calculator too, so you know how to do it. Okay, so we see that, but you guys, we're not seeing the top because we know that point is 0, 14. So I'm going to go to my window and I'm going to change my y max. I'm going to go to 20, let's say, just to get a better picture. Okay. Now remember, I don't really care about anything going on here. This is only the first quadrant is the part of his graph, or the part of his jump that's actually happening. So I'm going to find my 0, okay, by doing left bound, right bound. Okay, so we need a positive y, we need a negative y. The guess just hit enter, and we get 0.94. So this is approximately 0.94, 0. Okay, so here it says how long will it take him to reach the water. You guys, you need to remember the water is here. So the ground, the water, things like that. He's jumping from here into there. Well, how long will it take him? How long is an x value? So if this is my time in seconds, it's going to take him, he starts at 0. The whole jump goes from 0 to about 9.4. So it takes about 0.94 seconds for him to hit the water. Okay. Now, what's a reasonable domain and range? Okay, so again, think about what your domain is. Domain is time. Okay, so if domain is time, we are starting that at 0. Okay, that's obviously, we're going to start timing at 0. But then once he hits the water, the jump is over. So is my domain. I don't care. So it's from 0 to about 0.94. For my range, okay, range is describing our height. Sorry, my writing's getting pretty sloppy here. All right, so the lowest that we care about is this 0 right here when he's in the water. The highest he goes is 14, and I think it's feet. Yeah. Okay, the highest he goes is 14 because that's where he starts from. So my range will go from 0 to 14. It should be a 0, sorry. Okay. So take these, practice. You have your homework. Take your time with it. Okay. Domain and range is not difficult as long as you don't rush. Okay. And then obviously come see me in the morning with questions. I have to be in